One of the most important types of polynomial functions, especially in terms of applications, is that of the quadratic function. That's what we're going to look at today. Now, if we're looking at quadratic functions, what they are second degree polynomials. And so if we look at the graph, depending on if the quadratic function is positive or negative, if the quadratic function is positive with the leading coefficient, it'll look something like this, a u. If it's negative, it'll look something like this, an upside down u. It's got one bend in it because it is a second degree polynomial. 1 degree for the entrance and 1 degree for the first bend. Now there's an important part on every graph of a quadratic function, and that's the point at the tip, either at the bottom or the top. We call that point the vertex. And that vertex tells us a lot about the graph itself because it's really the starting point. So we'll often express quadratic formulas in what's called vertex form to highlight where that vertex is located. Vertex form is f of x equals some number times x minus h squared plus k. And we remember the h being subtracted from the x is a horizontal shift, and the k is a vertical shift, which means the vertex will be shifted to the right h and up k. The vertex is h comma k. So let's look at how we can use that to identify an equation. Let's say I have this graph. And we're going to put the vertex at 2, 3 and a y-intercept at 0, 1. And since it's symmetrical, there's also another point over here at 4, 1. It's not as important as the other two. But we can see our quadratic function forms this parabola, the upside down u, and we can come up with the equation of this parabola, of this quadratic, by using vertex form. We know it's going to be f of x equals some a times x minus the horizontal shift was 2, squared, plus k, the vertical shift of 3. And you can see where that vertex of 2, 3 falls right into that function. We still don't know what a is. That takes a little bit more work, and that's where the y-intercept or any other point can be helpful to help us find that. If we plug 1 in for the solution and 0 in for the x, we can solve what's left for the a. First off, we'll do the 0 minus 2 is negative 2, and negative 2 squared is 4. So we have 1 equals 4a plus the 3, and that's going to give us a simple equation we can quickly solve by subtracting 3 from both sides, giving us negative 2 equals 4a, and dividing by 4. So we have a is equal to negative 1/2. Put that all together then, and our function for this quadratic is f of x equals a, which is negative 1/2, times x minus 2, the horizontal shift, squared, plus 3, the vertical shift, and we've got the function of our graph. Vertex form is really helpful because it can really help us identify that vertex really quickly by just looking at the equation, or find the equation quickly by looking at the graph. But there are a couple other forms that we'll see with quadratics that we should be aware of. The first is called standard form. Standard form looks like f of x equals ax squared plus bx plus c, where a, b, and c are going to be numbers, any number. Now with standard form, it's a lot more difficult to identify the vertex, but we can do it. There is a formula to find the vertex, but we have to find the x and y coordinates separately. For the x coordinate, it's going to be equal to the opposite of b over 2a. And for the y coordinate, y is equal to f of whatever that opposite of b over 2a simplifies to. So, for example, if I have 2x squared minus 12x plus 26, the x coordinate is going to be the opposite of b over 2a. Remember, a is the number in front of x squared, b is the number in front of x, and c is the number added to the end. So when we do the opposite of b, the opposite of negative 12 is positive 12, over 2 times a, which is 2. So we have 12 over 4, which reduces down to 3. Now I know the x-coordinate of my vertex is 3. To find the y-coordinate, I just plug that 3 in for all of the x's. So we have 2 times 3 squared minus 12 times 3 plus 26, or y equals 2 times 9, doing exponents first, minus 12 times 3 plus 26, or y equals 18 minus 36 plus 26, and y is equal to 8. And so now I know my vertex is at the point 3, 8 for this graph. While vertex might take a little bit of work to get in standard form, something that's easy to see in standard form is the y-intercept. The y-intercept is simply found by making x equal to 0. I'm going to scroll up a bit so we can see that green quadratic that we were talking about. The idea is now I can replace all the x's with a 0, and that'll tell me what the y-intercept is on the graph quite quickly. So we would have 2 times 0 squared minus 12 times 0 plus 26. And what's really nice about standard form is multiplying by 0 just goes to 0, and so we can see the y-intercept pretty quick by just glancing at a standard form equation to be 26. Now while the y-intercept is straightforward, the x-intercept are going to take a little bit more work. To find the x-intercepts, we have to use a formula that is called the quadratic formula. The quadratic formula still uses that ax squared plus bx plus c. And it says that the x-intercepts are when x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now that's a complex looking formula, but it is one that helps us find the x-intercepts of any quadratic. So let's do another example. Let's start with 2x squared minus x minus 6. Again, remember, a is in front of x squared, b is in front of the x, and c is the number by itself. Since there's no number in front of x, I know b is going to be negative 1. No written number is assumed to be 1. So if I plug it into my formula, x is equal to the opposite of b. The opposite of negative 1 is positive 1. Plus or minus the square root of b squared, negative 1 squared, minus 4 times a, which is 2, times c, which is negative 6, all over 2 times a, which is 2. And then we just have to simplify this. It takes a few steps. We have 1 plus or minus the square root of 1 squared is 1. Notice I've got two negatives multiplied together. A negative times a negative is a positive. 4 times 2 is 8. 8 times 6 is 48. all over 2 times 2, which is 4. So I have 1 plus or minus the square root of 49 all over 4. And I can actually do the square root of 49. I could do it on my calculator, or I might just know that that is 7. So I have 1 plus or minus 7 all over 4. Now you might have been thinking, what is that plus or minus for? That plus or minus means we really have two answers that are squeezed together with shorthand. So if I have taken the square root, that means I can simplify it out into two different directions, one with the plus and one with the minus. If I do 1 plus 7 over 4, I get 8 over 4, which reduces to 2. If I do 1 minus 7 over 4, I get negative 6 over 4, which reduces to negative 3/2. These are the two x-intercepts that we have just found. Now this example was nice because it's simplified all the way down to a nice fraction or whole number. That doesn't always happen though. Let's look at another example. Let's do x squared plus 6x minus 4. And I remember that formula, just to write it again, opposite of b plus or minus the square root of b squared minus 4ac all over 2a, a good formula to commit to memory. So when we plug this in to find the x-intercepts, x is equal to the opposite of b, which is negative 6. A is 1, b is 6, c is negative 4, plus or minus the square root of b squared, 6 squared, minus 4 times a, which is 1, times c, which is negative 4, all over 2a, which is 1. Well, now we have negative 6 plus or minus the square root of 6 squared, which is 36. Again, a negative times a negative is a positive. 4 times 4 is 16, all over 2, which gives us negative 6 plus or minus the square root of 52, all over 2. Now what you might see here is we cannot take the square root of 52. So we could say we're pretty much simplified there at that point. We could put the square root of 52 in our calculator and we would get a decimal. It's a little more than 7, a lot less than 8, maybe 7.1, 7.2, and we could simplify from there. But that's kind of the idea, though, of how that standard form works. Now, why do we care? Well, quadratics specifically have a lot of useful applications that come up. For example, if a ball, or anything really, is thrown up from a point 40 feet tall, let's say from a 40-foot tall building, at 80 feet per second. Its height over time is modeled by this function. H of t is equal to negative 16t squared plus 80t plus 40. Turns out everything that's falling down to Earth, or falling down to any planet really, anything that's falling follows a quadratic motion. To kind of get a visual of what's happening here, we've got the ground, there's a building on the ground, and somebody on top of the building here at this dot has thrown something in the air, it's a ball, throws it up into the air, and then it eventually falls down to the ground. We're going to be interested in a couple questions. The first question we're going to ask is, when does the ball reach maximum height? Well, if I look at the graph, the maximum height is right here. It's at the vertex. So what we're really asking for is the x-coordinate, or in this case, the t-coordinate, because t is our variable, the t-coordinate of the vertex. Well, we have a nice formula in standard form for the vertex. It's the opposite of b over 2a. So if we label a, b, and c, the opposite of 80 over 2 times negative 16, or negative 80 over negative 32, and if I divide those, I'll get 2.5 seconds. So after 2.5 seconds, the ball has reached its maximum height, which begs the question, what is the maximum height? Well, the maximum height, that's getting at the h of t. How tall is it? That's the y-coordinate of the vertex. And so to get the y-coordinate of the vertex, we just plug 2.5 into the function. And we have negative 16 times 2.5 squared plus 80 times 2.5 plus 40. And you could put the whole thing in your calculator if you wanted, but I'm just going to work through it step by step. 2.5 squared is 6.25 plus 80 times 2.5 plus 40. Negative 16 times 6.25 is negative 100, plus 80 times 2.5 is 200, plus 40, which gives us 140 feet. So now I know that after 2.5 seconds, the ball is 140 feet in the air. A third question we might be interested in is when does it hit the ground? When we ask when does it hit the ground, we're interested in this bottom point where the height is 0. Well, if the height is 0 at that bottom point, that's really asking for the x-intercept. So, to find the x-intercept, we know we can use the quadratic formula, where x is equal to the opposite of b, negative 80, plus or minus the square root of b squared, 80 squared, minus 4a, which is negative 16, times c, which is 40, all over 2a. If we simplify this, we should be able to find when it's going to hit the ground. So we have negative 80 plus or minus the square root of 80 squared. I'm just going to actually put this all in my calculator in one step. 80 squared minus 4 times negative 16 times 40 is 8,960. Square root of 8,960 over 2a. Whoops, we know what a is. A is negative 16. So 2 times negative 16 is negative 32. Then I'm going to do two possibilities, one with the plus and one with the minus. And I'll just type in my calculator negative 80 plus the square root of 8,960. And that's going to be 14.65 over negative 32, which equals negative 0.458. If I do the minus, 80 minus negative 80 minus the square root of 8,960, I get negative 174.66 divided by negative 32, which is equal to 5.46. Now remember, we're talking about time. The ball's not going to hit the ground at negative 0.48 seconds, so I can throw that out. So it's more likely going to be the positive answer, because that's the only one that makes sense. So after 5.46 seconds, the ball will hit the ground. Things traveling through space is one great application of quadratics. Another great application of quadratics comes from marketing if you're trying to maximize your revenue at the correct price. A newspaper has 84,000 subscribers. at a cost of $30 per subscriber. Research suggests for every $2 increase, they lose 5,000 subscribers. Elasticity of demand, right? What should they charge? To ultimately maximize their revenue. Well, one important thing to know is the way we calculate revenue, or the amount of money that comes in, is we take the number of things that are sold and we multiply by the price. If you sell 5 things for $2, 5 times 2 is $10 in revenue. And so in this case, right now for the revenue, they've got 84,000 subscribers times the $30 that every person is paying. Right now their revenue is $2,520,000. Now, if we are going to do X increases of $2 each, what's that impact going to be on the revenue? Well, we're going to lose subscribers, so that N is going to reduce. There were 84,000 subscribers, but we're going to lose or subtract 5,000 subscribers for every X, or every increase of $2. Times the price. Well, what's happening to the price? Well, the price was 30, but it's increasing $2 for every single one X of these increases. We want to maximize our revenue. It turns out that this is going to be a quadratic, and the maximum revenue is going to happen at the top. So that is the vertex. But this isn't in standard form right now. We have to get to standard form, and the way we can do that is we can multiply out the right side. By distributing, we'll do 84,000 times 30. It's 2,520,000. Then we distribute the 84,000 on the 2x, so we get plus 168,000 x's. Then we'll distribute the negative 5,000x onto the 30, gives us negative 150,000. And then we distribute the negative 5,000x onto the 2, gives us negative 10,000x squared. I'm going to simplify this with our revenue equation. We usually put the x squared in front for a quadratic, so we'll do negative 10,000 x squared. Then I'm going to combine the x's. That should have been 150,000 x, sorry. Combine the x's in the middle. 168,000 minus 115,000 is 18,000 x's. And then finally, we've got the 2,520,000 at the end. Now we want the vertex to figure out what they should charge. X is the number of increases. And on the vertex, we know the vertex is the opposite of B over 2A. So if we label them A, B, and C, which gives us the opposite of B, which is negative 18,000, over 2 times A, which is negative 10,000, multiplying 2 times 10 is negative 20,000. And if I divide that on my calculator, I get 0.9. Now be careful here. The question is asking, what should they charge? X is the number of $2 increases. N is the number of people that subscribe. That's the first factor. P is the price they charge. That's the second factor. So to calculate P, the price they should charge, we'll do that factor of 30 plus 2x, 30 plus 2 times 0.9, or 30 plus 1.8, they should charge $31.80. If they charge $31.80, they're going to make more revenue than they currently do, and they'll have to print fewer papers, which reduces the cost, which increases the profit, and so that is the best price they should charge, and they know that because of solving for the vertex of the quadratic. All right, it's your turn to practice with these quadratics. Let us know if you have any questions.